Доброго дня, шановні. Перепрошую. Sorry. Dear colleagues, we open our poster session. We have three talks today, and we can start. All are ready. Okay.
Yes.
Okay, so the first presentation is Cognitive Technologies and Competence Development Bibliometric Analysis, presenter Tatiana Ivanova. Please start presentation, and you can will start, but we all have 10 minutes for a presentation and 5 minutes for discussion. Okay?
Okay,
Please.
okay.
Please.
Yes. I'm sorry, I want to start, but 1 minute, please. I can't start my presentation.
Okay. We see a presentation. Okay. Now. Please start. Please begin. Unmute microphone, please.
Do you hear me?
Yes. Yes.
I start again, okay? Good day, dear colleagues. My name is Tatiana Ivanova. I am PhD and assistant of professor from the National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnical Institute. I want to present my research, cognitive technologies and competence development, bibliometric analysis. One of the current areas of research that is attracting more and more attention is the use of cognitive technologies for the formation of competencies. In today's world, where digital innovations are changing and areas of life, these technologies have great potential to influence people's development and learning. The purpose of my research is a bibliometric analysis of cognitive technologies and competence formation. The aims of my research to answer the following questions regarding cognitive technologies and competence building. Which journals are the most influential? Which authors publish research on this topic? In which countries are the authors interested in this topic? What are the main thematic categories of research? How heavily cited are works on cognitive technologies and competences? What terminology is used to conduct research on the relevant topic? Can you hear me? Because I have some sounds. Do you hear me?
Yes, yes.
Yes. Okay, I'm sorry. The equation was used for this research from database Scopus. 281 documents were retrieved from the Scopus database search. Certain documents were selected for search and analysis using four stage. At the first stage, studies related to the Russian Federation were excluded. The removal of this publication is due to the war and aggression that Russia has launched against Ukraine. As a result, 11 studies were excluded. In the next step, all publication except articles, conference papers, books, chapters, and books are excluded. As a result, 33 studies were excluded and 237 documents were obtained. As a result of the third stage, articles published in 2023 and before 2013 and not in English were removed. For result, 84 documents was excluded. At the fourth stage, articles were analyzed by title, abstract, and main overview. As a result, the materials of 60 studies related to the specified direction will be used for the research. The received articles are loaded into Microsoft Excel for analysis and information visualization using the WOS Viewer software. First step, it is analysis of journals. A total of 60 documents were published in 36 resources. In result, 86 published percent, only one documents of this topic. The rest, 14% published from 2 or 3 documents. In the table 1 presents the top 5 most productive journals. This top 5 journals published 18% of the total number of publication. As you can see, Q workshop proceedings conference published the most research, namely 3 articles. It is 5%. Second step of our research is about authors. The 5 most productive authors regarding the cognitive technologies and competence development you can see in the table 2. Ines Gonzalez in the first place with 2 publications, both of which are first author. Ana Jimenez Zarco, who was 2 publications, ranks second. Next, the authors of 1 publication as the first author is Adinda, and not the first author is Adeniaju and Adilbayeva. Next, figure 1 presents the analysis of co-authorship by authors created using WOS Viewer. Figure 2 shows the top 5 countries with the largest number of publication. Overall, the country with the highest number of publication is Indonesia, which with 9 papers accounts for 15% of the total number of published articles. In the second and third place are China and Spain, which have 8 documents and 13%. In fourth place is Taiwan with 4 documents and almost 7%. Also in the top 10 countries are Finland, Greece, Kazakhstan, United States with 3 documents each, and India and Italy with 2 documents each. Figure 3 shows the top 4 organizations with the largest number of publications. With the result of the research of organizations, the leading place is occupied by Spain. It is Universitat Oberta de Catalunya with 3 publications, Universitat Politecnica de Valencia 2 publications. In the second place is Indonesia. This is Universitas Negeri Yogyakarta with 2 publications. Next step is analysis of subject categories. As a result of the research, certain thematic categories were defined. They are presented in figure 4. The top 5 categories are computer science with 35 articles, social science with 25 articles, engineering 16 articles, business management and accounting 5 articles, and energy also 5 articles. Fifth steps is analysis of citation. A corresponding study was conducted on the citation of author and organization among the selected articles. The results of the analysis of the top 5 cited authors are presented in table 3. As a result of the analysis, it was found that the most cited article is Berjali Ben Hassan Eritali on the topic a novel adaptive e-learning model based on big data by using competence-based knowledge and social learning activities. As a result, this study currently has 43 citation, which is almost 30% in the top 5. Analysis of citation bar authors is shown in figure 5. This figure was created by using WOS viewer. Figure 6 shows the result of the citation analysis of organization whose author published articles on the given topic. And the last step of our research is term analysis. The analysis of all terms used in the articles is shown in the figure 7. In particular, 2 main clusters are highlighted, which are formed by all keywords. The main cluster is formed by such keywords as artificial intelligence, learning, teaching, and machine learning. The study analyzes the Scopus publication database from 2013 to 2022 to analyze the cognitive technologies and competencies. It was found that cognitive technologies show significant potential in improving learning processes and developing competencies, providing access to innovative methods and tools. They enable students and employees to develop critical thinking, problem solving, and creative thinking, communication skill, and other important competencies. Also, cognitive technologies can be successfully used in various spheres of our life, including education, business, medicine, and others. They allow personalizing the education processes, adapting its individual needs and abilities of each participant. Thank you.
Thank you. Please, questions. Okay. Please explain me who are stakeholders of your research.
Thank you for the question. It's hard to explain. I was
who may be consumer of information that you generate that you generate in your research?
It's my own theme. I think this theme about the cognitive technologies is relevant now, and I think I want to study this theme, about cognitive technologies and competence development. I think it's important for students today, now for employees, maybe some researcher.
Thank you.
Also interested in the theme.
Thank you. More questions, please. No? Thank you. Thank you. Please shut down your presentation.
One moment, please.
Thank you. The next our presentation is smart system in STEM education. Presenter Tatiana Ischenko. Tatiana is here?
Yes.
Yes, please start presentation.
Just 1 second, please. Do you see my presentation? Do you see our presentation on your screen?
Yes.
That's good. So once again, good afternoon, dear colleagues. Thank you very much for a great opportunity of presenting our research to you.
Please, full screen mode, please, of your presentation.
Full screen? Just 1 second, please. Full screen. How can I do it? How can I do full screen?
Слева внизу показ слайдов. 4.
Oh, sorry. So, like this?
F5.
F5, sorry. Where is our F5?
Functional button 5.
Just 1 second, please. Slide.
Have trouble. Okay. Please start your presentation.
Terribly sorry for the inconvenience. Find it.
Okay, please,
Okay, let
please
it be
present.
quick.
Mhm.
So our topic is smart systems in STEM education. And first of all, let's have a look at the very definition of our smart systems. So they refer to intelligent and interconnected technologies that leverage advanced computing, data analytics in various aspects of modern society. So these systems incorporate a combination of sensors, algorithms, and communication networks together analyze and access of data that is enabling them to make informed decisions and perform tasks autonomously or with minimal human intervention. So our smart systems play a great impact in our lives and play an important role that can be seen in the following cases. And you can see them on your screen here. Efficiency and automation. It can streamline operations in manufacturing, transportation, energy management, and various other sectors. Sustainable resource management facilitates intelligent monitoring and control of resources such as energy, water, and waste. And they help identify patterns, predict demand, and optimize consumption. Enhanced safety and security also contributes to public safety by detecting and responding to emergencies. Additionally, they can enhance cyber security measures by identifying potential threats. So our consumer convenience are these smart systems have made daily life more convenient by enabling connected devices and Internet of Things applications. They offer smart home automation and other devices that personalize recommendations and their convenience. Also, there are other roles which are also very important, and you can read them about them in our research paper. Therefore, the main point of interest of the present paper is to consider smart systems within STEM education. To achieve this goal we suggest to consider the following items. Define main models of smart systems, define key features of STEM education, consider various models and technologies uh, for STEM education within smart systems. Also, let's have a look at main smart systems in modern education. So they refer to the integration of advanced technologies, intelligent tools, and data-driven approaches, which enhance the learning process. They improve educational outcomes and optimize administrative tasks. In education, smart systems encompass a range of applications and tools that support various aspects of the educational ecosystem, including teaching, learning, assessment, administration, and communication. Smart systems refer to networks of interconnected devices and applications. And let's have a close look at smart systems used in modern education. And the first, very important, is learning management system that serves as a central hub for organizing and Then adaptive learning platforms. These platforms assess each student's strengths and weaknesses and learning styles, and then provide personalized content and recommendations to address their specific needs. Virtual reality, here students can explore virtual environments, interact with digital objects, and simulate real-world scenarios. Artificial intelligence are quite simple. It provides personalized guidance and support to students. Our tutors can adapt their teaching strategies and provide additional resources. Our There are also very interesting, for example, gamification, right? Gamification involves incorporating game elements such as rewards and challenges and leaderboards into their learning process. It motivates students and makes learning more enjoyable. Our mobile learning allows students to access educational context anytime and anywhere. So these systems offer interactive exercises and collaborative features, making learning more flexible and convenient. However, smart systems also come with challenges such as privacy and security concerns. Next slide, as you can see, what STEM is. So STEM in modern education has become a global phenomenon, with many countries investing in STEM education programs to develop the skills of their workforce. For example, STEM education emphasizes hands-on and experimental learning that encourages critical thinking, problem solving, and creativity. It aims to provide students with a strong foundation in scientific and mathematical concepts. We can find STEM applications in many countries in Europe, in Asian countries, and also in Islamic countries. For example, in Europe, European countries recognize the importance of this subject in preparing students for the changing demands. And, for example, Finnish schools emphasize the importance of student-centered, collaborative learning and focus on the development of critical thinking. As for Asia, for example, China and Japan, they have also made emphasis on improving the quality of science education in primary and secondary schools, not only in universities. In Islamic countries, we can say that STEM education has also gained significance in many Islamic countries. There are also efforts to integrate Islamic values and principles into STEM education in some countries. For example, Saudi Arabia, United Arab Emirates, Turkey, and Malaysia. Um, Next slide shows us very interesting approach. So, sorry. When it comes to STEM learning in the context of smart systems, there are several models and approaches that can be employed to engage students and foster their understanding of those complex systems. So here we see a few models commonly used in STEM education. So let's have a close look at each of them. And the first is project-based learning. It emphasizes hands-on learning and real-world problem solving. In this model, students work on projects that are designed to address complex problems and challenges. They typically work in groups to design and plan and executive projects that require them to apply their knowledge and skills from multiple subject areas. So more details about this approach you can find in our article, and these are just main features. As for our design thinking, for example, it is also a problem-solving approach that focuses on empathy, creativity, and iteration. It is a valuable framework, and it allows students to tackle complex problems related to smart systems by considering their needs, exploring innovative solutions, and refining their design. Here is how you can integrate design thinking into STEM education with a focus on smart systems. Next very important approach is inquiry-based learning. It is a student-centered approach that fosters active exploration, questioning, and investigation. Students can explore and investigate the technologies, applications, and implications of intelligent systems. And here is some examples how it is possible to integrate smart systems into inquiry-based learning for STEM education. Yeah? Of course, there are critics of inquiry-based learning who note that open-ended nature of inquiry means that students may require more time to explore topics, conduct research, and reach conclusions. Next is gamification, which I love very much. So simply put, gamification is the use of game principles in non-game context. It promotes problem solving, teamwork, and motivation. And here is some examples. How can you incorporate this program into the smart system, into STEM education? Uh, Also, this gamification approach has both pros and cons. The supporters say that by stimulating practical scenarios, students can understand how STEM concepts are relevant and applicable in various contexts. But opponents say that there is a risk of students focusing more on the game mechanisms rather than understanding educational uh, content. And collaborative learning methods or model involves students working together in groups to solve problems,
You have
discuss
one
ideas.
minute.
Okay, okay. I will be shorter and share knowledge. Again, some examples. And here you see some technologies for teaching STEM in the context of smart systems. They play a crucial role, and first of all, because of their relevance to the real world, from smart homes to industrial automation. Um, Introducing these technologies in STEM education, we can help students understand their practical applications. Um, and there are, well, these are three most widespread technologies. And over the last several years, the Department of Education and Science has started a number of educational projects aimed at increasing the interest of students in various sciences or areas of science. And this is one of such projects. It is called Smart Life, which includes which which has got two steps here for this modernization of hidden system and creation of smart life. So perfect example. Again, here all these
So,
technologies can be applied.
sorry,
Mhm.
but time over.
Okay, so just to finish it up, I have to say that smart system technologies open up a world of possibilities for students. By incorporating them, students can engage hands-on and experimental learning, and that's very important for our students to prepare for better life. Thank you very much. If you have any questions, I will be very glad to answer.
Thank you. Please, questions.
Can I ask
Please.
the question?
Yeah,
Uh,
yes,
what smart technologies are the most popular while using STEM education?
Thank you very much for your question. As I have already told you that we have chosen a number of technologies, and they are all very important. But from my point of view, one of the most popular and important is project-based learning, design thinking, maybe inquiry-based learning, and gamification. But teachers should choose the one they love best according to the goals for their education and take in account the students. I mean, the level of students to fulfill its goals.
Thanks.
Thank
Uh,
you.
thank you. More questions? Okay. Please tell me, do you see some contradiction between new approach to learning and the existing organization of learning process in our higher education?
Thank you for question is very important and exit one because we have to more to do to in order to uh, order our students to be ready for the future and to compete in their future career, they have to apply some new methods and models. But it is not very easy for our teachers to incorporate them in learning. So there is a kind of contradiction because of their unwilling, put so, of our teachers. Our teachers are not always ready to incorporate new methods, but they have to if they want their students to compete in their profession.
But I consider, for example, the next situation. The principal methods for planning teachers' work in the university is estimating amount of auditorium presence. But the modern methods stimulate to move teachers' work outside of auditory. Is it true?
Yes, definitely. Sometimes, yes, definitely. So,
But and we have the contradiction because, for example, a teacher don't want to use the new methods because your efforts would not correctly estimate.
yes, it's partly true. So, as I've already told you, that teachers sometimes are not ready themselves to incorporate these methods, but they have to. It's time taken, it's effort taken. Our teachers, as we as teachers, we have to learn something new and be ready to share it with our students, not only in a room, in auditorium, but also outside it. So, these methods or these approaches, they are very good for that.
Thank you. Thank you. More questions? No. Thanks. Please shut down your presentation.
Mm-hmm. Yes.
Our next presentation, creation of the effective educational environment for the development of soft skills of future primary school teachers by means of cloud technologies, by Olga Vasko, Oksana Belir, Svetlana Kondratyuk, and Natalia Pavlyuchenko. Who is presenter? Someone of other are here or no? I see the no. In this situation, we complete our program. Thank you for your presentations. Thank you for your participation in our conference. And I hope that we will meet next year.
Thank you very much indeed.
Goodbye.
Thank you.
Goodbye. Thank you.